So there's two different kinds of solving in this one, the graphing and then the substitution. So this is the solving. You would graph your line. So this is, I think this is Amber's. Amber actually plugged in points. You could also take your lines and graph them, this one and then this one, which would have been y equals negative 2/3 x plus 6. And then just keep working your slope until they cross, and they cross at 3, 4. Remember the two special cases are there. If they never cross, that's no solution. And then if they end up being the same line, it's all real numbers. Then came substitution. So this is Sophie. Sophie solved for x first and got that x would equal 5 minus 3y, and then took that and plugged it back into the other one. Pretty much everybody did the same thing because x was already by itself. And then you should have gotten -1, too. Remember that for these kinds of questions, you'll always answer them in coordinate point form. This is a Canvas quiz, which means you're going to be typing those answers in. They will be parentheses, -1, -2, no spaces, okay? It's not an x equals -1, y equals 2. It is in coordinate point form, okay? So keep in mind those things while you're obviously doing doing your homework on that kind of stuff. What will this look like on Canvas? WebAssign gave you the parentheses, Canvas won't. All right, then the third one, and I did it both. I took both. I took Oliver's and I took Michelle's because Michelle got rid of the decimal. So she multiplied here everything by 100, which moves the decimal. Please, 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 biggest mistake people make here is forgetting to go across the equal sign with that 100, okay? So then she solved the bottom one, which I thought was easier too, for y. You could have done x or y. Got that y was 25,000 minus x. Plug that into the other equation. Solve for x first and got 13,500. And then because they summed to 25,000, so you subtracted that from 25,000 and got 11,500. So the format on a question like this would be blank at 2%, blank at 4%. So just know that you'll separate those ones out. You don't need to put them in coordinate point form, because you establish which one's the x and you establish which one's the y, so it could be switched. Okay. And then Oliver did not get rid of the decimal. He kept it as 0.02 and 0.04, which is also fine. Solved. This time he solved for x, and he got that x equals 25,000 minus y. So he got the y first, being 11,500, and then subtracted it from the 25,000 to get the, God bless you, to get the x, which is 13,500. So I said it yesterday, but you could see different types of relationships with these, not yesterday, on Monday, but between these numbers. So both this one and the example in the notes on Monday said the total invested, and so you did x plus y equals a certain number. But you'll see, like on the quiz review, I'll give you a little bit variation, but it could say he invested, in this case it would be $2,000 more at 4% than at 2%, and you'd have to set up your equation that way. So it would be like y equals x plus 2,000. And then you'd have this equation and this equation, and you'd set up your system that way. So just keep that in mind. It doesn't always have to, I'm not always going to give you the total amount invested. You could get some sort of relationship between those two. Okay, so we're going to jump into 7.2, and then hopefully I'll get time to answer those questions for homework at the end. You were offered 2 jobs selling college textbooks. One company offers an annual salary of $34,000 plus a year-end bonus of 1%. The other company offers an annual salary of $25,000 plus a year-end bonus of 2%. What's the minimum you'd have to sell in a year to make the second offer better than the second offer, the better offer? So I've got to figure out how much I would make in that first company and then the second. So the first gives me $34,000 plus a percentage of my sales. So if x equals my sales plus 1% of my sales, that equals the amount of money I earn. So that could be equals your y. The second company gives you $25,000 plus 2% of your sales. And I want to know what's the minimum you'd have to sell in a year to make the second offer the better one. So I want the 25,000 plus 2% x to be greater than or equal to, actually I want it to be greater than, because I want it to be the better offer. But really all you have to do is find the break even here. So I have to find the midpoint, which is just setting them equal to each other. And that would be 25. Well, let me get rid of the decimal. So I'd have to multiply everything. 2% would be 0.02. Everything by 100, this would be 25, 1, 2, 3, 1, 2, plus 2x equals 3, 4, 1, 2, 3, 4, 5, plus 1x. And then subtract the x. So x would equal, subtract the 25, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 9. So I'd have to have $900,000, which is a lot, in sales. I guess it depends on what you're selling. Textbooks, that's a lot of textbooks. $900,000 in sales would be my break-even amount. Okay, so that's kind of what it was looking for. Anything over that would make it worth it. Yeah.
How come you multiplied everything by 100?
To get rid of the decimal. So that 2% is 0.02. And the 1% is 0.01.
Oh, okay. So you can just like, okay.
Yep, I had to move the decimal twice, which means multiply by that many zeros. So 100. Okay, so this question is just like the last one with different numbers. It says you're offered 2 jobs selling textbooks. One company offers the annual salary of $31,000 plus the bonus of 1%. So that's the 31 plus a 1% times your sales. The other is $29,000 plus the 2% of your sales. And again, you want the minimum to have to sell to make the second offer better, but really we just need the break even point. So this would be 0.01, this would be 0.02. So 31,000.01x equals 29,000.02x. You can multiply everything by 100 here, or I can actually simplify this a bit. This would be 2,000 plus 0.01x equals 0.02x. Subtract the 0.01. 2,000 equals 0.01x. You can multiply by 100, and I'd get 200. Add on 2 zeros equals 1x, which is just x. So here is the $200,000 worth of sales you'd have to have in order to make that second one a better offer. Okay, this question says solve by substitution. Use the graphing utility to verify your results. So the first thing I would want to do is get rid of the decimals here. So if I can multiply this by 10 and this also by 10, I'd get 5x plus 32, sorry. Y equals 105. And 2x minus 16y equals negative 30. So now I want to solve one of these for one of the variables. Let's just say we pick this one. 2x would equal negative 30 plus 16y. Divide everything by 2. X equals negative 15 plus 8y. Hi. Okay, so now I'm going to take this and I'm going to plug it into this x. So 5 times negative 15 plus 8y plus 32 equals 105. Distribute here. Combine my like terms. Oh, this should be, sorry, that should be 32y. So those are not like terms. These are my like terms. Here. So these, negative 75 plus 72y, 105. Add the 75. And divide by 72. So I know 9 goes into both of these, 20 and 8, and then reduce it one more time. 4 goes into both of those, 5 over 2. So that's the y coordinate. And then take that and plug it back in. So if I plug it back into here, x equals negative 15 plus 8 times 5 over 2. Negative 15 plus 20, which is positive 5. And that completes your ordered pair. Then use the graphing utility to do that. We're going to have to solve these. So I would say you're going to have to solve this for y. You can take these that are already divided or multiplied by 10, or you can use the original ones. It doesn't matter, but I need to solve them for y. So if I take this and I would do 32y equals 105 minus 5x and then divide everything by 32. As long as you group together that numerator, you can type it in just like that. And then the same for This one, I would get negative 16y equals negative 30 minus 2x, and then divide everything by negative 16. And again, as long as I group together this numerator, you can enter it in your graphing utility just like that. Then zoom out, because actually you don't have to zoom out, but if you double tap on that graph, this is going to show up as 2.5, but it is the same thing. All right, this one says solve the system graphically and then verify your answers algebraically. So I'm going to bring in a coordinate grid. And first I'm going to graph my line. So this would be negative 2y equals negative 4x minus 16, and then divide everything by negative 2. So y equals 2x plus 8. So I go up to positive 8, up 2 to the right 1, or down 2 to the right 1, and my line looks like that. Now I want to do my parabola. So x squared would equal, actually, sorry, x squared plus 7y would equal 11. Two options here, which is to plug in the points or get this in a standard form. Start by doing that. That's 7y equals negative x squared plus 11, divide by 7. And I get y equals negative 1/7 x squared plus 11 over 7. So this means it's going to point down, and it means it's going to be shifted up. 11 over 7 is 1 4/7. It's going to point down, and it's going to be super wide. So it's going to, I mean, like go something like this, right? So we're going to need to plug in some points. So if I were to keep going back on this, the first time, if I were to count down from here, down 2 over 1, down 2 over 1, down 2. The first time this even crosses the x-axis is at negative 4, and it's not going through there. You could check it, but it's not going through there. So if the next one I want to plug in would be like negative 5, if I plug in negative 5, and it's easiest to either plug it in here before we start dividing, I'd get negative 5 squared plus 7y equals 11, 25 plus 7y equals 11. This would be negative 14. Y would equal negative 2. So does my coordinate point cross at negative 2 for my purple line? Yeah, if I go down 2 and over 1, it's going to continue on. So if I keep doing that, it's going to happen again. It's going to happen again. So now I have a better understanding of what this graph looks like. I know one cross point is that. It would be negative 5 and negative 2. And then if I continue to plug in other points, if I were to plug in negative 6, it wouldn't happen. Negative 6 squared, 7y equals 11, 36. So this would be 7y equals negative 25. And that's not a whole number. So then if I went to negative 7, negative 8, the next one that's going to happen is at negative 9. So if I did negative 9 squared plus 7y equals 11, this would be 81. Subtract the 81. Negative 70, and I get y equals negative 10. So then again, check your purple point and see if it crosses through negative 9, negative 10. So if I kept going with that purple down to and to the right 1, this coordinate point is negative 9, negative 10. So this specific one was a little rough just because you had to keep plugging in points. The one on your quiz that is graphing is much more obvious, so you don't have to keep going beyond the coordinate points. Oh, wait. 7-2 is the last, well, not the last of the room, because we're going to figure out how we're going to learn how to solve systems using matrices. But the last ones that you've been exposed to that you remember, which is elimination. So solving systems of linear equations with two variables using elimination. Some books call it addition. Sometimes it's the easiest pick, but just keep in mind that you want to be able to bounce back and forth. If I give you something that has an equation that's already solved for a variable, it's going to be easier to use substitution. If I give you an equation that they're both in standard form, it's going to be easier to use elimination, okay? So just be flexible. Unless it says you have to do this method, you will have that choice. So there is for sure going to be at least one question on your quiz and test that tell you have to graph it. And I'm going to give you the graph on an answer sheet. So you will have to do that method. Doesn't mean you can't check it using substitution or elimination, but you are going to have to graph it. The rest of them could be a choice. So this is, and it's a lot of words, but hopefully it will like remind you of what we're doing here. We're gonna get both equations in a standard form. So you want your x's in a line, you want your y's in a line, and you want your constants to be on the other side. If you need to, you're gonna change one or both equations so that when I combine or add the equations, one of the variables cancel out. Then I'm gonna actually combine those equations. One of the variables will go away, and I'm gonna solve for the remaining variable. Then I take that variable, plug it into either the original equations or what we changed, and solve for the other variable. And then just like substitution, there's two special cases. If both variables cancel out and the statement is false, then it's no solution. If both variables cancel out and the statement is true, it's all real numbers. So if I end up with something like 0 equals 0, that's true, it would be all real numbers. If I end up with something like 0 equals 2, that's false, it would be no solution. All right, so solve using elimination. So the first thing we want to do is make sure the x's are in the line, the y's are in the line, the constants are. It's already done for us, right? Now I want to see if when I add these, will a variable cancel out? Will it? No, so I have to change one or both of them. How could I do that? So I could multiply both equations by -2. That's one option. What's another option? Both equations by 3, and it's going to cancel the y, right? Do whatever you saw to do first, I would do. My advice is avoid the negatives if you can. That's when people make silly mistakes. So I probably would have recommended going with 3, but we'll do the -2. Just people make dumb mistakes when dealing with negatives. So if you can avoid it, do it. So this becomes -2x plus 2y equals -18. We go all the way across. 2x plus 3y equals 13. And then I'm adding these. So the x's cancel, which was our goal. 5y equals -5. Divide both sides by 5. And y is -1. Now I want to take that and plug it back in. And I can plug it back in to this original equation. I could plug it back into this original equation. I could even plug it back into the one I changed. But if you got part of it wrong, you're going to continue to get wrong. So my advice, plug it into an original. And the simplest one, so like maybe this. X minus a -1 equals 9. X plus 1 would equal 9. And x would equal 8. So coordinate point here, because it's x, y, would be 8, -1.
Does it matter which way that we use?
Nope. Which way what?
Like, does it matter if we use elimination or the other way?
So there's going to be one question that says you have to use graphing, and then the rest are your choice. So even the word problems that you did at the end with your interest, I think it's easier to use elimination sometimes.
I've kind of been doing elimination the whole time.
So you just want to be prepared to have to do one way if it asks you. And sometimes, like, you'll have an equation like this, right? And then sometimes you're going to have an equation that says x equals 9 minus y. And that's easier to use substitution. So you kind of I bounce back and forth depending on how the equations appear in the beginning. Yeah. But as long as you know how to do at least the graphing, because it's going to force you to do the graphing, you can use the other ones. All right, this one, again, solve using elimination. So what can I do with A? I can just add them. I get 2y, this cancels, equals 30. Divide both sides by 2, y is 15. Take that, plug it back in, and it doesn't matter which one. So if I plug it back into the bottom, because it's positive, I'd get x equals 5. And again, I can check all of these answers by taking them and plugging them back in. They'd have to work for both. And you obviously don't want to do that unless you know you have extra time. But here it would be 15 minus 5, that equals 10. And here it would be 15 plus 5, and that equals 20. So that's an easy check. All right, what can I do with B? Good. So I can't just add them, and I can't just change one. I have to change both, right? My advice is stick with the ones that are positive, negative already. Again, avoid the negatives if you can. So I can multiply the top by 5 and the bottom by 2, and I'm going to cancel out the y's. So this becomes 15x plus 10y equals 20. And the bottom becomes 4x minus 10y equals negative 58. And then I add, and I get 19x. These cancel, equals negative 38. Divide both sides by 19. X equals negative 2. Now I take that and I plug it back in, and again, it can go into either the originals or my changed one. I'm just going to grab the top one because 4 is smaller than 29. 3 times negative 2 plus 2y equals 4. Negative 6 plus 2y equals 4. 2y equals 10, and y equals 5. Gianna, you're not driving that car, right? Okay. Things that never used to happen in normal class. Questions on that one? And again, I could take it, plug it back in, and check it. All right, so notice the directions change this time and say use any method to solving. So you literally can choose which method. Obviously, I would avoid graphing if at all possible. I would say your choice would be between substitution and elimination. Which is the easiest to solve for? Elimination, it's already set up that one is positive and one's negative, right? So all I have to do is add it. 7x, these cancel, 42. X is 6, take that, plug it back in, and you can plug it back in anywhere, but let's say we plug it back into the top. Negative 5, subtract the 6 here, would be 15, and y is negative 3. Oops, yeah, negative 6, negative 3. You could have also done substitution. If you add the 5y to the other side, you could plug it in, so it's completely up to you. I would try to read the equation and see which way it's set up for. That would be the easiest. Questions on that one? Obviously, you are going to see fractions like we saw with substitution. You're going to see decimals like you saw with substitution. You want to get rid of them when you can, okay? And again, you're going to have the same two like special cases. Yep.
So, but isn't the x positive?
Oh, it is positive. Yeah. Wait, did I plug it in as negative? No, I just wrote it wrong. I started writing the 3.
Oh, okay.
Yeah, sorry. Thank you. All right, then you're going to get word problems dealing with in this section. Okay, so all the word problems are going to get looped together in your systems questions. This one says find the equilibrium point of demand and supply. So equilibrium point is kind of like the break-even point, but it's a point, which means it has two parts. When I ask you for the break-even, I'm asking for the number of units you have to sell in order to break even. So there's only one part to that answer. So break even, we set them equal to each other. We solve it. We only want the x. That's break even. How many units do I, and we always round that up. How many units do I have to sell in order to not be negative? The equilibrium is supply and demand. So you find a model for demand, you find a model of supply. The good thing is you guys don't have to create those. These will be done for you. And then equilibrium point is the x and the y. So it's the number of units and the price per unit. So x stands for the number of units, and y, or in this case it's p. P stands for the price per unit. So you want to find not only what's the optimal amount of units to sell, but what should I sell it at? So these are both equal to p, right? Which means I have a system, two variables, two equations, but I don't even have to like rearrange them. I can just set them equal to each other because p equals p. I can use substitution here and say 380 minus, or plus, sorry, 0.1x would equal 500 minus 0.4x. So I'm just using substitution to set them equal to each other. Now how do I solve for x? I can add the 0.4. So 380 plus 0.5x equals 500. Then what? Subtract the 380. 0.5x equals, that would be 120. Then what? Divide by 0.5. And I could get rid of the decimal, right? It could be 1200 divided by 5. It's the same thing. So it would be 240. That's the number of units I want. To find the price per unit, I have to take that x and I have to plug it back in. Doesn't matter which one I plug it back into. No. So look at your answers and look at your options. Is it easier to multiply by a 0.4 or is it easier to multiply by a 0.1? A 0.1. So I'm going to use this one. So P would equal 380 plus 0.1 times 240. P equals 380 plus, this means move my decimal one place, 24, which is 404. So when it asks for the equilibrium point, it's 240 units at $404 per unit. So you want to know not only your number of units, you also want to know your price per unit. And on Canvas, it would be like blank units at blank per unit. I'll probably even put the dollar sign there. So you know, hopefully, like it jars you to be like, oh, I have to plug them in as separate things. Now you could have like rearranged those equations and set it up using elimination if you'd prefer elimination. You could have multiplied everything by 10 here to get rid of the decimals. You just have to remember to multiply it times everything. So it'd be 3800 plus 1x equals 5,000 minus 4x. And then you could solve it that way. I will tell you right now, you're not going to be able to use a graphing utility on this quiz. So if you have a scientific calculator that you're comfortable with, you can use it. If not, I'll give you the scientific calculator on lockdown. Those are going to be your options, okay? But a graphing utility, nope. So get used to that. Obviously, there's questions in the last section that said graph using a graphing utility. Those won't be on your quiz. Yep.
So once you get the x, it doesn't matter which one you plug it into?
Nope. Okay, last one. This says a minor league baseball team had a total attendance one evening of 1,175. The tickets for adults and children sold for $5 and $3.50 respectively, which means, in that order, the ticket revenue that night was $5,087.50. A says create a system of linear equations to find the number of adults and children at the game. B says solve your system of equations by elimination or substitution. C, use a graphing utility to verify your solution. So we've got to set up the system first, okay? What are my two variables? A and C. What does A represent?
A is the adults and then children is the C.
Good. Number of adult tickets. C, number of children's tickets. For me, it makes sense to make them A and C. You can make them X and Y. But the reason why A and C is easy is because when I get to the end, I know what I've solved for. I don't have to go back to what I set it up. All right, so what is one system or one equation I can set up based on the information I'm given?
5a plus 350c equals 5,087.
Good, so the money brought in would have to be used multiplying the money that was sold for each ticket times the amount of tickets. So 5a plus 3, and I can make it to 3.5, but 350c equals $5,087.50. And again, in a minute, I'll go through and get rid of those zeros because we don't need them. What's the other equation I can use?
A plus c equals 5,000.
Good. A plus C, the number of A tickets, number of adult tickets plus the number of child tickets would be 1,175. That's my system. Now I need to solve it. So since these are not significant digits here and here, I would actually get rid of them because I don't want to have to multiply by 100 when I could just multiply by 10. Okay. You have options. You can either use substitution or you can use elimination. I think both are kind of equally easy here because one, the bottom, all I have to do is move one of the variables to make it substitution. Two, if I'm using elimination, I only have to multiply one thing. Obviously, if like you didn't have a calculator, I would say get rid of your decimals, but the fact that you have a scientific calculator, you don't really have to do that, right? Let's say I wanted to solve, let's say I want to cancel out the a's. What could I multiply the bottom equation by? -5. So I could do -5, and I get -5a minus 5c equals 1,075 times 5. -5875. Now I can add that with this one. These cancel. I get -1.5c equals 5875 minus 5087 point, oops, 0.5787.5. Divide that by the 1.5, and C is 525. First of all, can you have a decimal there? Can you sell a partial ticket? No. So if this was asking like how much did they go for, then yes, I could have a decimal, okay? But if it's asking how many tickets they sold, which is what's happening here, you cannot have a decimal. You can't sell partial ticket. So there are 525 children's tickets sold. How do I find out how many adult tickets?
Subtract that from 1175.
Good. If they both sum to 1175, then I just want to subtract it here, and I'd get 650 adult tickets.
If we had a decimal there and you have to round, we can round either way, right? So like,
If you have a decimal, you did something wrong.
in any of the problems, is that possible?
No. If it was like, if you're trying to figure out if money, like so much money was put in here or there, then you can have a decimal. It should terminate at cents, but you can have a decimal. But like if it's a number of things, a number of items, it can't be a point. Anything.
You said in
The last thing this one says is to use a graphing utility to verify your solution. So I have to solve for one of the variables, and it doesn't matter which one. I don't have an x and a y here, so I could just pick one. So let's say I want to solve this equation for a. I'm going to do 5a plus 3.5c equals 5,800. Subtract the, what did I say? I'm going to solve for a. Subtract the 3.5c. So that's gone. And then divide everything by 5. So when I write this in the calculator, this could be my y. $5,087.50 minus 3.5c, which that could be my x, can get divided by 5. And I don't have to work that out. I could literally group it. So when I type that in the calculator, parentheses 5087.5 minus 3.5x, close the parentheses, divided by 5. And then my second one, much easier, a plus c equals 1175. So a would equal 1175 minus c, or y would equal 1175 minus x. And then graph. Oh, I should have done this on the graphing utility. Hang on. So I zoomed out a lot on this graph so that you could see it, and that's way easier to do on your graphing utility. That's your app. But notice here is my point, 525 and then 650.